Hello, class. We are going to have topic 37 and 38 today. Intro to polynomial functions. Add and subtract polynomials, which is lesson 9.1. To start, we'll have the following vocabulary. A polynomial is an expression with multiple or a single term separated by a plus or a minus sign. Um, Exponents of a polynomial must be whole numbers, meaning they should be positive as well. Not fractions, all right, and not variables also. The degree of a polynomial is the highest exponent present in a polynomial. The polynomial is said to be in standard form when all the terms are written in this decreasing order according to their exponents. Leading coefficient is the coefficient of the leading term of a polynomial written in standard form. Let's have an example for that one. Supposing I have 2x squared plus 7. Okay, so the leading term in here is obviously the first term, 2x squared. All right, the coefficient of this leading term is going to be the number in front of the variable part. Okay, so let me make that into a 20. So the number in front of x to the 20th power is 2. So that will be your leading coefficient. Okay. Now, the constant term is a term that does not have a variable part. In this polynomial, the constant term would be 7. It is the term that does not have a variable part. We have a monomial when we have exactly one term. An example of that would be, all right, that will be an example. A binomial has exactly terms. And let's have an example for that one. Supposing I have 2x cubed plus 5. So see how it has two terms. And then the trinomial has three terms. Let's have an example of a trinomial. Okay. All right. Now moving on to the different types of polynomials. The first one is called the constant polynomial, which has no variables. Okay, let's have an example of this one. Let's say I have 5. Plus 3 is a constant polynomial. You don't see any variables. Linear polynomial has a degree of 1. That means the highest exponent will be 1. All right. And then we have the quadratic polynomial. It has a degree of 2, meaning the highest exponent of the polynomial is going to be 2. Then we have cubic polynomial has a degree of 3. We have an example for that one. Let's say 4x cubed. right? And then we have the quartic, which has a degree of 4. Let's have an example. Finally, we have the quintic polynomial, which has a degree of 5. Have an example. All right. Now, moving on. For polynomials, we cannot have a fractional exponents. You cannot have negative exponents and variables within the radical or square root sign, and you cannot have a division by a variable. Also, you cannot have infinite number of terms. Let's try the following examples. Decide whether function is a polynomial. If so, write it in standard form and state its degree, leading coefficient, and constant. Now, if you look at a, f of x is equal to negative 2x squared plus 4 minus 3.7x plus 9x to the fourth, it qualifies as a polynomial because you don't have any fractional exponents, you don't have a variable exponent, and you don't have a division by a variable. All right, so to write this in standard form, we are going to write it in decreasing exponents. So I will say f of x is equal to 9x to the fourth minus 2x squared minus 3.7x plus 4. Okay, so it is a quartic. It's a quartic polynomial. Next, we're also tasked to state its degree. So the degree is 4, and it is called a quartic polynomial. All right. The leading coefficient will be the number in front of our leading term, which is 9. And then the constant term is the term that doesn't have a variable part, which is going to be 4. Okay. Now, this one has a negative exponent and a variable exponent. So that tells us that this is not a polynomial. All right. Why? Because it has negative exponent and also has a variable exponent. Well, for letter C, see how we have a fractional exponent. So this is also not a polynomial because we have fractional exponent. All right. Then for this one, see how we have a variable, division by a variable. So these are some of the guidelines, right? That will help you determine whether you have a polynomial or not. What we have. So this is not a polynomial because you have a division by variable. All right. Now let's talk about function notation. F of x is often used in math instead of writing y. Well, f of x is also equal to y. They mean the same thing. Now, when we read this, it doesn't mean f times x. It means that the x is the input value that is going to be the number that is going to be plugged in. So f of x is read as f of x, f of 2 is read as f of 2. Here, we're going to use the equation y is equal to 3x minus 5 to evaluate the following, f of 2. So when we say f of 2, that means every time we see x, it will be substituted by the input value of 2. So this will then be 3 times 2 plus 5. 3 times 2 is 6. Plus 5 is 1. So therefore, f of 2 is equal to 1. Okay, moving on to another one. Letter B. We have f of negative 1. So this time, every time we see x, it will be substituted by negative 1. So 3 times negative 1 will be negative 3 minus 5 is negative 8. So f of negative 1 is negative 8. And here we have f of 0. This time we substitute 0 for x. 3 times 0 will be 0. Minus 5 will be negative 5. So f of 0 is negative 5. So here we are given f of x equal to x cubed plus 5x squared minus 5x minus 7. We're tasked to find f of negative 4. So we'll say f of negative 4, since the value of x is negative 4, every time we see x, it will be substituted by negative 4. So x cubed will be negative 4 cubed plus 5x will be negative 4 squared there plus 5x will be negative 4 and then minus 7. Okay. All right. Now, next step, we are going to have negative 4 cubed, and then I will just grab my calculator. So negative 4 cubed is like saying negative 4 times negative 4 times negative 4. So that would be negative 64. Here, be careful. You don't multiply first. You work with the exponents first. Remember the order of operations. So we'll have negative 4 squared will be 16. All right. And then we'll have negative 5 times negative 4 will be positive 20, then minus 7. Next, we can have negative 64. 5 times 16 will give us 80. And then 20 minus 7 is 13. All right. Then we have negative 64 plus 80 is 16 plus 13. That will give us 29. So f of negative 4 will be 29. Now, to add or subtract polynomials, we add or subtract the coefficients of like terms. Two terms are like if they have the same variable and same exponent. Let's do the first one. So I have x squared plus 12x plus 12. What I'll do in here is to write a second polynomial in such a way that the like terms are going to be in the same column. Okay. Now working from left to right, 19 plus 7 will be 26. You simply add the numeric coefficients and then keep the variable part. 12 plus 10 will be 22 x, and then 12 plus 13 going to be 25. So there are no more like terms, so this will be our final answer. All right, so that's how we add. Now in subtraction, I will also rewrite them so that the like terms are going to be in the same column. So I have negative 5x squared plus 8x plus 6. I'm writing them in standard form. And then I have what 2x cubed minus 3x squared plus 7. Okay, so we're tasked to subtract. When you're tasked to subtract, the first thing that you do is to change the sign of all the terms in the second group. Okay, so this is 2x cubed. The sign is positive. We'll change it into negative. Negative into positive. Positive into negative. After changing the sign, you are going to proceed with the rules of addition. So right now, we're going to proceed with addition. This does not have a matching pair, so we'll just write it down as 2x, bring it down as negative 2x cubed. Then here, negative 5x squared plus 3x squared will be negative 2x squared. Okay, and then no matching pair for this, so we just simply bring it down. And then we add 6 and negative 7. That will give us negative 1. All right. So this will be our final answer. Okay, so that concludes our lesson for today.